Now, the problem of perception may not seem very hard. There are trees and people and rocks and planets and monkeys in the world, and you see them and you know what they are. It's not immediately obvious that this is such a difficult problem. There's a story, and I'm not sure it's true, but there's a story of a very famous AI researcher, artificial intelligence researcher, in the 60s, who set himself the project of building a robot. And he worked on his most complicated parts. But of course, the robot, to make its way through the world, had to be able to see and identify objects. So the story goes that he assigned a graduate student this problem as a summer project. You have nothing to do for the next few months, figure out how we recognize things. And psychologists love this story because it nicely expresses how simple the problem of perception looks, but how hard it actually is. So if the story is true, the graduate student never really did finish the project. And in fact, we've been working along the project of object recognition in computers and artificial intelligence for many, many years. And only recently are we seeing some progress. So I used to be able to say, when I gave this lecture about 5-10 years ago, that there's no machine that comes close to what humans can do regarding recognizing things. And machines are getting better and better. And I have a feeling that one day I'll give this lecture and I can't say that anymore. One day it'll be machines from Facebook or Google that really can recognize objects at the ability of a person. But they aren't there yet. So if you're one of these people who thinks that object perception is easy, you might have a conception of something like this, where what happens is, you see the world through your eyes, and then you're sitting in your head, in your skull, looking at some sort of computer screen that indicates the world as it is. And this is, for instance, a depiction in a Terminator movie, where you see the world through his eyes, and what you see is the world, annotated with some symbols and some figures, but basically the world. But of course, that can't solve the problem. That just pushes the question back. Because now the world has been encapsulated into a screen, a computer screen, but how do you recognize things on the computer screen? You've solved nothing. And so the better way to think about perception is, well, you have the eye, which is a fleshy, gooey sort of thing. And then you have the retina, and light hits the retina, and the retina is a bunch of nerve cells, and these nerve cells fire. And they fire at some stimulus and not others. And then so you get is basically the equivalent of this, an array of numbers corresponding with the intensity of firing, where one number is fire, 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 another number is fire, 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 fire. And now you have an array of numbers. And then the problem of perception is, out of this array of numbers, this shifting array of numbers, you have to extract objects and people. Where people are, what they're doing, what things are shaped, what colors things are, what depth things are, and so on. And now you could sort of see why this is difficult. And one way to imagine this is that in order to, it's a certain mathematical problem. Your array is a two-dimensional array. That's all that's going on in your eye. And you need to infer a three-dimensional world, which is what we got there, what you think about, from a two-dimensional information. And it's mathematically impossible to do this with certainty. It's like backwards multiplying. When given a compound number, you can't easily determine the unique numbers that gave rise to it, because there are multiple numbers consistent with that compound number. And similarly for the world. Imagine most of your retina is silent, nothing's firing. But there's neurons firing that corresponds to a shape. And the shape is this irregular polygon you see here. So what's in the world? Well, you don't know. For instance, you don't know how far away it is. The irregular polygon, to fill up this amount of the space in your brain, can be right next to you. It could be floating in space a foot away from you. Or it could be 1,000,000 miles away. So think about the moon. The moon, you're looking at a full moon in the sky, takes up some circular space on your eye. And how do you know that it's not a foot away, or 10 feet away, or 1,000,000 miles away? Nothing in the information an eye per se tells you. You also don't know what shape this is. So maybe it's the shape that you see it as, an irregular polygon. Or maybe it's a square that's been tilted back. So how do you tell? For everything you see, there's an indefinite number of possibilities as to the actual real world things give rise to it. And I'll give you real examples of this coming up. And I want to do it in terms of color, actually brightness, in terms of objects and object recognition, and in terms of depth. And for each of these, I'll suggest that we have unconscious assumptions in the head about how the world works that helps us take these indefinite number of interpretations and narrow it down to get to the right one.